So let's look at when we call a function to be onto or surjective. What does it mean? So I'll give you guys two examples. This is an example of onto, while this is not a onto. So we are looking at a scenario wherein things are not onto. So the relation, in this case it turns out to be a function 2, is going to relate A and B, wherein A is going to get divided with, or can divide B, sorry. A can divide B. So set 1 and set 2 looks like this. This is your output. But this is not onto. While the next case, wherein we have the same definition but different sets. This is an example of onto. So what is the difference? This is an example of onto, while this is not an example of onto. Why is it so? This is, while that is not, while this is. This is onto, while this is not onto. So what is the difference? The difference is the output, every element of the output is not part of an input. Okay, so let me put it across. I'm giving an example of things when they are not onto, right? So I have, say, got a few outputs, while say I have few input, and now if I happen to miss out few inputs, like in this case these two are missing out, they're not being related to any input, not being related to any input, then we call it as not onto. Actually it's not an official name, but yeah, this is not onto. Example is your greatest integer function. It's a good example. So that's your greatest integer function. So what does it do? For any input, it will round it up to the lowest possible integer. That is, if I have an input of 2.95, my output is 2. And the next value, that is 3, for example, if I go to 3 or 3.24 in this case, I'll get an output of 3. That is, if I want an output of 2.5 or any decimal number, I can never get it. I can get only integers as output. So in this case, all the possible values other than integers are missing from the output. So 2.4 is not part of the output, 2.5 is not part of the output, 10.27 is not part of the output, 113.67 is not part of the output. So all these are not part of the output, right? So in such a case wherein things are not, elements from the output are not being related to any input, it's a it's called, actually it's not called per se, it's not onto. Another example is modulus function. So modulus function is over here. So no way I can get an output of negative, right? I can get only positives. If I want negative output, if I want to go down over here, no, I can't, right? If I want to go down, if I want to go get -4, no, I can't get -4. You can see the graph is not going towards -4. So which is, or what is an example of onto? Well, an identity function. So if I want an output of -5, I can give an input of -5. If I want an output of say 3.5, I can give an input of -3.5. So every possible output has a possible input. Okay, so this is not onto, while your identity function is onto. Right, something like this. So what is the official definition? A function f mapping x to y is said to be onto or surjective if element of y is image of some element of x under the function f. That is, for every y belonging to y, that is your set y is over here, there exists an element x in your capital X set such that f of x is equal to y. That is, whatever output I talk about, there should be some input. So no one should get missed in your codomain. So basically your range should be equal to codomain. I hope you guys understand the word range and codomain. Only then this will make sense. Okay. Every possible output value is reached by at least one input value. So that is your onto. Now pause and copy everything.